Hi students. So in this lecture we're going to talk about the compounds of D block elements. Okay? We have already covered the applications of D block like the photography and the toning. We have covered all these things, right? So now we will start the compounds of D block elements, and the first compound is K2Cr2O7. Its name is potassium dichromate. Okay? So first we will talk about its preparation. In this method, what do we take? We take iron chromate. Now this is the formula for iron chromate, Fu.Cr2O3. The same thing can be written as combinedly as FeCr2O4. You can write the same thing in a combined form. That is also correct. We react with sodium carbonate along with oxygen, and we heat it around 1000 to 1300 degrees Celsius. This results in the formation of Fe2O3 and Na2CrO4, sodium chromate, and carbon dioxide gas is released. Kindly note that Fe2O3 is insoluble in water, whereas Na2CrO4, sodium chromate, is soluble in water. Okay, so we dissolve in water and we filter out FeO2O3 because that is insoluble. So by the help of filter paper, we can easily separate Fe2O3. And once we have separated the Fe2O3, we have only left Na2CrO4, right? Now the CO2 gas is released. So I have written in the key point also. In this case, we take CaO along with that. Means during this process, we also take CaO. So what is the role of calcium oxide? Calcium oxide keeps the mass of Na2CO3 porous. It keeps the mass of Na2CO3 porous, and Na2CO3 has also one role. It also has a tendency of absorbing CO2 gas. So it absorbs CO2 gas, and calcium oxide keeps the sodium carbonate fluffy, porous, so that it can absorb more and more CO2 gas. Okay, that's the purpose. Moving ahead, we have dissolved the solution in water and Fe2O3 is separated out by filtration. I have already explained. Then we are left with Na2CrO4, and now we treat it with concentrated sulfuric acid. When I treat it with concentrated sulfuric acid, that changes into Na2SO4 and sodium dichromate, Na2Cr2O7, which will be red color. Now the question comes out to be, now we have Na2SO4, sodium sulfate, which is also known as salt cake. Why we preferred this method? The purpose was to prefer this method because Na2SO4 has a specific characteristic. It has a tendency, like it has a different behavior. What is it? So when you increase the temperature, kindly listen. When you increase the temperature gradually, then initially the solubility of sodium sulfate increases. The solubility of the sodium sulfate increases up to 32.4 degrees Celsius. And on further increase in temperature, the solubility of Na2SO4 starts decreasing. And that's the reason this logic is very, this application, this characteristic is very useful for us for the separation. So we maintain a suitable temperature, let's say 150, 160, whatever it is, so that the whole Na2SO4 becomes insoluble, and it is separated out by crystallization. So this behavior of Na2SO4 helps us to separate it during this step. Hope you have understood. The solubility first increases and then solubility decreases on further increase in temperature above 32.4. And then further we treat with Na2Cr2O7 with potassium chloride. Double decomposition takes place and we get potassium dichromate, K2Cr2O7. Hope it's clear, guys. If I show you the points I have already mentioned. See, why do we use CaO? We have written this thing. Now further I have also mentioned what is the logic behind uh, like using Na2CO3 earlier, right? So because we are getting Na2SO4 and then we are doing double decomposition reaction and then we are getting the K2Cr2O7, right? Hope this point is clear out. But then you may have a question, sir, if I use K2CO3 instead of Na2CO3, means in place of Na2CO3, if I use K2CO3, then what will happen? So this, you can think about this question, right? Then we can directly get K2Cr2O7, right? Then why did we prefer the first method? Why can't we prefer this method? Why can't we prefer this method? Because if you do so, everything is fine, everything is fine, everything is fine. Means you will do the same thing here, you will get K2CrO4, and when you further treat with concentrated sulfuric acid, you will get K2Cr2O7 and K2SO4. Now at this step, at this stage, to separating both of them will be a very challenging task because both things have equal solubility, and that's the reason it is very tough to separate them. That's the reason we are following this method, not this. Hope you got this question. I hope this part is very clear and I have written the key points very clearly, right? Now again we will further discuss about the characteristics of chromate or dichromate ion. If you see the chromate ion, its color is yellow. If you keep it in acidic medium, means if its pH is lesser than 7, the chromate ion changes into Cr2O7. Dichromate, whose color is orange red. Or if you supply basic medium to dichromate, then this will change into chromate. These are their characteristics. Behavior: chromate in acidic medium gives dichromate, dichromate in basic medium gives chromate. That's what we call it as effect of pUH. You can clearly see chromate in acidic, dichromate, dichromate in basic, chromate. Hope it's clear. Moving ahead, Na2Cr2O7 and K2Cr2O7 are strong oxidizing agent. Now one more thing I would like to explain, that in volumetric analysis, like volumetric titrations and all analysis and all, when we do the titration, we prefer K2Cr2O7 but we avoid Na2Cr2O7. Why? Because Na2Cr2O7 is deliquescent in nature. The sodium of Na2Cr2O7 is deliquescent because its size is smaller than potassium, and because of which it has high polarizing power, and because of which it will absorb or attract more water molecule. It will have water or moisture absorbing tendency. It will have moisture absorbing tendency, and so we may not get the accurate readings. That's the reason we don't prefer Na2Cr2O7, we prefer K2Cr2O7. Okay, and this is what I have written clearly. The readings will be wrong in the titration process. Hope this point is clear. So now we will again further start discussing about Cr2O7 2 minus dichromate ion. If you see, you have to memorize this structure. This is a structure and all the bonds are covalent bond. Okay, all the bonds are covalent bond. Now here we have a single bond and its bond length is 176 picometer. The bond angle is 126 degree, and the double bond length is 163 picometer. Kindly note negative single double. What I mean to say, this negative charge is in conjugation with double bond. Means it is looking like single bond, but in actual here also we have a partial double bond because negative charge is in conjugation with double bond. यहाँ पर resonance आ रहा है, and that's why even this bond length, this bond length, this bond length, all three are same. Even this, all three are same. So I have added two questions. Number of identical Cr and oxygen bond 6. कैसे 6? 1, 2, 3, 4, 5, 6. And total number of Cr oxygen bond 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Hope it's clear. Now one important reaction which is very important. Dichromate in acidic medium reacting with peroxide gives you CrO5, and CrO5 will have butterfly structure. I hope you know this structure. This is a structure. Okay. Now we will move ahead. I have already covered all these things. Now we will discuss about oxidizing nature of Cr2O7 2 minus in acidic medium. So dichromate in acidic medium changes into Cr3 plus. This behaves as a strong oxidizing agent. Here the oxidation state of chromium is plus 6 changing into plus 3, plus 6 to plus 3, and I minus changing into I2, means it is getting oxidized. Similarly, Sn plus 2 going oxidized to Sn plus 4. H2S undergoing oxidation to give sulfur. Fe plus 2 giving to Fe plus 3. Okay, these are the oxidizing nature of dichromate ion in acidic medium. Now effect of heating on dichromate. So suppose if you heat dichromate strongly, you will get chromate, and then you will get Cr2O3, and then also you will get oxygen. So you need to memorize this reaction. On heating dichromate, you will get chromate, Cr2O3 and oxygen. Very important reaction. Now Cr042 minus means chromate in acidic medium. As I said, chromate in acidic gives you dichromate, right? Earlier I have explained this part here. But again I'm telling this part. Again I'm telling because this is very important. So the chromate ion is in equilibrium with dichromate ion. The chromate ion is in equilibrium with the dichromate ion, and if you alter the pH, if you change the pH, then it can be interconverted. Means if you go for higher pH, then dichromate will change into chromate. But if you go for lower pH, means acidic medium, you will get dichromate. Okay guys, so this is all about the preparations and the basic properties and chemical properties of dichromate ion. In the next session we will talk about potassium manganate and potassium permanganate. So that's all for the session guys. Thank you very much.